Encrypting Data at Rest. Ken Beer. Ryan Holland. November 2014. Contents. Contents Abstract Introduction. The key to encryption. Who controls the keys? Model A, you control the encryption method and the entire KMI. Model B, you control the encryption method. AWS provides the storage component of the KMI while you provide the management layer of the KMI. Model C, AWS controls the encryption method and the entire KMI. Conclusion. References and further reading. Abstract. 2, 3, 4, 11, 12, 17, 19. Organizational policies, or industry or government regulations, might require the use of encryption at rest to protect your data. The flexible nature of Amazon Web Services, AWS, allows you to choose from a variety of different options that meet your needs. This white paper provides an overview of different methods for encrypting your data at rest available today. Introduction. Amazon Web Services, AWS, delivers a secure, scalable cloud computing platform with high availability, offering the flexibility for you to build a wide range of applications. If you require an additional layer of security for the data you store in the cloud, there are several options for encrypting data at rest, ranging from completely automated AWS encryption solutions to manual, client-side options. Choosing the right solutions depends on which AWS service you're using and your requirements for key management. This white paper provides an overview of various methods for encrypting data at rest in AWS. Links to additional resources are provided for a deeper understanding of how to actually implement the encryption methods discussed. The key to encryption. Who controls the keys? Encryption on any system requires three components: 1. Data to encrypt, 2. A method to encrypt the data using a cryptographic algorithm, and 3. Encryption keys to be used in conjunction with the data and the algorithm. Most modern programming languages provide libraries with a wide range of available cryptographic algorithms, such as the Advanced Encryption Standard, AES. Choosing the right algorithm involves evaluating security, performance, and compliance requirements specific to your application. Although the selection of an encryption algorithm is important, protecting the keys from unauthorized access is critical. Managing the security of encryption keys is often performed using a key management infrastructure, KMI. A KMI is composed of two subcomponents: the storage layer that protects the plain text keys and the management layer that authorizes key usage. A common way to protect keys in a KMI is to use a hardware security module, HSM. An HSM is a dedicated storage and data processing device that performs cryptographic operations using keys on the device. An HSM typically provides tamper evidence, or resistance, to protect keys from unauthorized use. A software-based authorization layer controls who can administer the HSM and which users or applications can use which keys in the HSM. As you deploy encryption for various data classifications in AWS, it is important to understand exactly who has access to your encryption keys or data and under what conditions. As shown in Figure 1, there are three different models for how you and or AWS provide the encryption method in the KMI. You control the encryption method in the entire KMI. You control the encryption method. AWS provides the storage component of the KMI, and you provide the management layer of the KMI. AWS controls the encryption method in the entire KMI. Figure 1, Encryption Models in AWS. Amazon Web Services, encrypting data at rest in AWS. November 2014. Model A, you control the encryption method and the entire KMI in this model. You use your own KMI to generate, store, and manage access to keys as well as control all encryption methods in your applications. This physical location of the KMI and the encryption method can be outside of AWS or in an Amazon Elastic Compute Cloud, Amazon EC2, instance you own. The encryption method can be a combination of open-source tools, AWS SDKs, or third-party software and/or hardware. The important security property of this model is that you have full control over the encryption keys and the execution environment that utilizes those keys in the encryption code. AWS has no access to your keys and cannot perform encryption or decryption on your behalf. You are responsible for the proper storage, management, and use of keys to ensure the confidentiality, integrity, and availability of your data. Data can be encrypted in AWS services as described in the following sections. Amazon S3 You can encrypt data using any encryption method you want, and then upload the encrypted data using the Amazon Simple Storage Service, Amazon S3, API. Most common application languages include cryptographic libraries that allow you to perform encryption in your applications. Two commonly available open-source tools are Bouncy Castle and OpenSSL. After you have encrypted an object and safely stored the key in your KMI, the encrypted object can be uploaded to Amazon S3 directly with a PUT request. To decrypt this data, you issue the GET request in the Amazon S3 API and then pass the encrypted data to your local application for decryption. AWS provides an alternative to these open-source encryption tools with the Amazon S3 Encryption Client, which is an open-source set of APIs embedded into the AWS SDKs. This client lets you supply a key from your KMI that can be used to encrypt or decrypt your data as part of the call to Amazon S3. The SDK leverages Java cryptography extensions, JCEs, in your application to take your symmetric or asymmetric key as input and encrypt the object prior to uploading to Amazon S3. The process is reversed when the SDK is used to retrieve an object. The downloaded encrypted object from Amazon S3 is passed to the client along with the key from your KMI. The underlying JCE in your application decrypts the object. The Amazon S3 encryption client is integrated into the AWS SDKs for Java, Ruby, and .NET, and it provides a transparent drop-in replacement for any cryptographic code you might have used previously with your application that interacts with Amazon S3. Although AWS provides the encryption method, you control the security of your data because you control the keys for that engine to use. If you're using the Amazon S3 encryption client on premises, AWS never has access to your keys or unencrypted data. If you're using the client in an application running in Amazon EC2, a best practice is to pass keys to the client using secure transport, for example, Secure Sockets Layer, SSL, or Secure Shell, SSH, from your KMI to help ensure confidentiality. For more information, see the AWS SDK for Java documentation and using client-side encryption in the Amazon S3 Developer Guide. Figure 2 shows how these two methods of client-side encryption work for Amazon S3 data. Figure 2, Amazon S3 client-side encryption from on-premises system or from within your Amazon EC2 application. There are third-party solutions available that can simplify the key management process when encrypting data to Amazon S3. CloudBerry Explorer Pro for Amazon S3 and CloudBerry Backup both offer a client-side encryption option that applies a user-defined password to the encryption scheme to protect files stored on Amazon S3. For programmatic encryption needs, SafeNet Protect app for Java integrates with the SafeNet Key Secure KMI to provide client-side encryption in your application. The Key Secure KMI provides secure key storage and policy enforcement for keys that are passed to the Protect app Java client compatible with the AWS SDK. The Key Secure KMI can run as an on-premises appliance or as a virtual appliance in Amazon EC2. Figure 3 shows how the SafeNet solution can be used to encrypt data stored on Amazon S3. Figure 3, Amazon S3 Client-Side Encryption from on-premises system or from within your application in Amazon EC2 using SafeNet Protect app and SafeNet Key Secure KMI. Amazon EBS Amazon Elastic Block Store, Amazon EBS, provides block-level storage volumes for use with Amazon EC2 instances. Amazon EBS volumes are network-attached, and persist independently from the life of an instance. Because Amazon EBS volumes are presented to an instance as a block device, you can leverage most standard encryption tools for file system level or block level encryption. Some common block level open source encryption solutions for Linux are LoopIce, Encrypt, with or without, Lux, and TrueCrypt. Each of these operates below the file system layer using kernel space device drivers to perform encryption and decryption of data. These tools are useful when you want all data written to a volume to be encrypted regardless of what directory the data is stored in. Another option would be to use file system level encryption, which works by stacking an encrypted file system on top of an existing file system. This method is typically used to encrypt a specific directory. Ecrypts and Encrypts are two Linux-based open-source examples of file system level encryption tools. These solutions require you to provide keys, either manually or from your KMI. An important caveat with both block-level and file system-level encryption tools is that they can only be used to encrypt data volumes that are not Amazon EBS boot volumes. This is because these tools don't allow you to automatically make a trusted key available to the boot volume at startup. Encrypting Amazon EBS volumes attached to Windows instances can be done using BitLocker or Encrypted File System, EFS, as well as open-source applications like TrueCrypt. In either case, you still need to provide keys to these encryption methods and you can only encrypt data volumes. There are AWS Partner Solutions that can help automate the process of encrypting Amazon EBS volumes as well as supplying and protecting the necessary keys. Trend Micro Secure Cloud and SafeNet Protect are two such partner products that encrypt Amazon EBS volumes and include a KMI. Both products are able to encrypt boot volumes in addition to data volumes. These solutions also support use cases where Amazon EBS volumes attach to auto-scaled Amazon EC2 instances. Figure 4 shows how the SafeNet and Trend Micro solutions can be used to encrypt data stored on Amazon EBS using keys managed on premises, via software as a service, SaaS, or in software running on Amazon EC2. Figure 4, Encryption in Amazon EBS using SafeNet Protect for Trend Micro Secure Cloud. AWS Storage Gateway. AWS Storage Gateway is a service connecting an on-premises software appliance with Amazon S3. It can be exposed to your network as an ISC disk to facilitate copying data from other sources. Data on disk volumes attached to the AWS Storage Gateway will be automatically uploaded to Amazon S3 based on policy. You can encrypt source data on the disk volumes using any of the file encryption methods described previously, for example, Bouncy Castle or OpenSSL, before it reaches the disk. You can also use a block-level encryption tool, for example, BitLocker or Encrypt/Lux, on the ISC endpoint that AWS Storage Gateway exposes to encrypt all data on the disk volume. Alternatively, two AWS Partner Solutions, Trend Micro Secure Cloud and SafeNet Storage Secure, can perform. Both the encryption and key management for the ISC disk volume exposed by AWS Storage Gateway. These partners provide an easy, checkbox solution to both encrypt data and manage the necessary keys that is similar in design to how their Amazon EBS encryption solutions work. Amazon RDS Encryption of Data in Amazon Relational Database Service, Amazon RDS, using client-side technology requires you to consider how you want data queries to work. Because Amazon RDS doesn't expose the attached disk it uses for data storage, transparent disk encryption using techniques described in the previous Amazon EBS section are not available to you. However, selective encryption of database fields in your application can be done using any of the standard encryption libraries mentioned previously, for example, Bouncy Castle, OpenSSL, before the data is passed to your Amazon RDS instance. While this specific field data would not easily support range queries in the database, queries based on unencrypted fields can still return useful results. The encrypted fields of the returned results can be decrypted by your local application for presentation. To support more efficient querying of encrypted data, you can store a keyed hash message authentication code, HMAC, of an encrypted field in your schema, and you can supply a key for the hash function. Subsequent queries of protected fields that contain the HMAC of the data being sought would not disclose the plain text values in the query. This allows the database to perform a query against the encrypted data in your database without disclosing the plain text values in the query. Any of the encryption methods you choose must be performed on your own application instance before data is sent to the Amazon RDS instance. Cipher Cloud and Voltage Security are two AWS partners with solutions that simplify protecting the confidentiality of data in Amazon RDS. Both vendors have the ability to encrypt data using format preserving encryption, FPE, that allows ciphertext to be inserted into the database without breaking the schema. They also support tokenization options with integrated lookup tables. In either case, your data is encrypted or tokenized in your application before being written to the Amazon RDS instance. These partners provide options to index and search against databases with encrypted or tokenized fields. The unencrypted or untokenized data can be read from the database by other applications without needing to distribute keys or mapping tables to those applications to unlock the encrypted or tokenized fields. For example, you could move data from Amazon RDS to the Amazon Redshift data warehousing solution and run queries against the non-sensitive fields, while keeping sensitive fields encrypted or tokenized. Figure 5 shows how the Voltage solution can be used within Amazon EC2 to encrypt data before being written to the Amazon RDS instance. The encryption keys are pulled from the Voltage KMI located in your data center by the Voltage security client running on your applications on Amazon EC2. Figure 5, encrypting data in your Amazon EC2 applications before writing to Amazon RDS. Using Voltage secure data. Cipher Cloud for Amazon Web Services is a solution that works in a way that is similar to the way the Voltage security client works for applications running in Amazon EC2 that need to send encrypted data to and from Amazon RDS. Cipher Cloud provides a JDBC driver that can be installed on the application, regardless of whether it's running in Amazon EC2 or in your data center. In addition, the Cipher Cloud for any app solution can be deployed as an inline gateway to intercept data as it is being sent to and from your Amazon RDS instance. Figure 6 shows how the Cipher Cloud solution can be deployed this way to encrypt or tokenize data leaving your data center before being written to the Amazon RDS instance. Figure 6, encrypting data in your data center before writing to Amazon RDS using Cipher Cloud Encryption Gateway. Amazon EMR Amazon Elastic MapReduce, Amazon EMR provides an easy-to-use Hadoop implementation running on Amazon EC2. Performing encryption throughout the MapReduce operation involves encryption and key management at 4 distinct points. 1. The source data. 2. Hadoop Distributed File System, HDFS. 3. Shuffle phase. 4. Output data. If the source data is not encrypted, then this step can be skipped, and SSL can be used to help protect data in transit to the Amazon EMR cluster. If the source data is encrypted, then your MapReduce job will need to be able to decrypt the data as it is ingested. If your job flow uses Java and the source data is in Amazon S3, you can use any of the client encryption methods described in the previous Amazon S3 sections. The storage used for the HDFS mount point is the ephemeral storage of the cluster nodes. Depending on the instance type, there might be more than one mount. Encrypting these mount points requires the use of an Amazon EMR bootstrap script that will do the following. Stop the Hadoop service. Create an encrypted directory to mount the encrypted file system on top of the. Install a Filesystem encryption tool on the instance. Existing mount points. Restart the Hadoop service. You could, for example, perform these steps using the open-source eCrypts package in an ephemeral key generated in your code on each of the HDFS mounts. You don't need to worry about persistent storage of this encryption key, because the data it encrypts does not persist beyond the life of the HDFS instance. The shuffle phase involves passing data between cluster nodes before the reduce step. To encrypt this data in transit, you can enable SSL with a Configure Hadoop Bootstrap option when you create your cluster. Finally, to enable encryption of the output data, your MapReduce job should encrypt the output using a key sourced from your KMI. This data can be sent to Amazon S3 for storage in encrypted form. Model B, you control the encryption method. AWS provides the KMI storage component, and you provide the KMI management layer. This model is similar to Model A in that you manage the encryption method, but it differs from Model A in that the keys are stored in an AWS Cloud HSM appliance rather than in a key storage system that you manage on premises. While the keys are stored in the AWS environment, they are inaccessible to any employee at AWS. This is because only you have access to the cryptographic partitions within the dedicated HSM to use the keys. The AWS Cloud HSM appliance has both physical and logical tamper detection and response mechanisms that trigger zeroization of the appliance. Zeroization erases the HSM's volatile memory where any keys in the process of being decrypted were stored and destroys the key that encrypts stored objects, effectively causing all keys on the HSM to be inaccessible and unrecoverable. When you determine whether using AWS Cloud HSM is appropriate for your deployment, it is important to understand the role that an HSM plays in encrypting data. An HSM can be used to generate and store key material and can perform encryption and decryption operations, but it does not perform any key lifecycle management functions, for example, access control policy, key rotation. This means that a compatible KMI might be needed in addition to the AWS Cloud HSM appliance before deploying your application. The KMI you provide can be deployed either on premises or within Amazon EC2 and can communicate to the AWS Cloud HSM instance securely over SSL to help protect data and encryption keys. Because the AWS Cloud HSM service uses SafeNet Luna appliances, any key management server that supports the SafeNet Luna platform can also be used with AWS Cloud HSM. Any of the encryption options described for AWS services in Model A can work with AWS Cloud HSM as long as the solution supports the SafeNet Luna platform. This allows you to run your KMI within the AWS compute environment while maintaining a root of trust in a hardware appliance to which only you have access. Applications must be able to access your AWS Cloud HSM appliance in an Amazon Virtual Private Cloud, Amazon VPC. The AWS Cloud HSM client, provided by SafeNet, interacts with the AWS Cloud HSM appliance to encrypt data from your application. Encrypted data can then be sent to any AWS service for storage. Database, disk volume, and file encryption applications can all be supported with AWS Cloud HSM in your custom application. Figure 7 shows how the AWS Cloud HSM solution works with your applications running on Amazon EC2 and an Amazon VPC. Figure 7, AWS Cloud HSM deployed in Amazon VPC. To achieve the highest availability and durability of keys in your AWS Cloud HSM appliance, we recommend deploying multiple AWS Cloud HSM applications across availability zones or in conjunction with an on-premises SafeNet Luna appliance that you manage. The SafeNet Luna solution supports secure replication of keying material across appliances. For more information, see AWS Cloud HSM on the AWS website. Model C, AWS controls the encryption method and the entire KMI in this model. AWS provides server-side encryption of your data, transparently managing the encryption method and the keys. AWS Key Management Service, KMS. AWS Key Management Service, KMS, is a managed encryption service that lets you provision and use keys to encrypt your data in AWS services and your applications. Master keys in AWS KMS are used in a fashion similar to the way master keys in an HSM are used. After master's key are created, they are designed to never be exported from the service. Data can be sent into the service to be encrypted or decrypted under a specific master key under your account. This design gives you centralized control over who can access your master keys to encrypt and decrypt data, and it gives you the ability to audit this access. AWS KMS is natively integrated with other AWS services including Amazon EBS, Amazon S3, and Amazon Redshift to simplify encryption of your data within those services. AWS SDKs are integrated with AWS KMS to let you encrypt data in your custom applications. For applications that need to encrypt data, AWS KMS provides global availability, low latency, and a high level of durability for your keys. Visit https://a.w.s.amazon.com/km/ or download the KMS cryptographic details white paper to learn more. AWS KMS and other services that encrypt your data directly use a method called envelope encryption to provide a balance between performance and security. Figure 8 describes envelope encryption. 1. A data key is generated by the AWS service at the time you request your data to be encrypted. 2. Data key is used to encrypt your data. 3. The data key is then encrypted with a key encrypting key unique to the service storing your data. Four. The encrypted data key and the encrypted data are then stored by the AWS storage service on your behalf. Figure 8, envelope encryption. The key encrypting keys used to encrypt data keys are stored and managed separately from the data in the data keys. Strict access controls are placed on the encryption keys designed to prevent unauthorized use by AWS employees. When you need access to your plain text data, this process is reversed. The encrypted data key is decrypted using the key encrypting key. The data key is then used to decrypt your data. The following AWS services offer a variety of encryption features to choose from. Amazon S3. There are 3 ways of encrypting your data in Amazon S3 using server-side encryption. 1. Server-side encryption. You can set an API flag, or check a box in the AWS Management Console to have data encrypted before it is written to disk in Amazon S3. Each object is encrypted with a unique data key. As an additional safeguard, this key is encrypted with a periodically rotated master key managed by Amazon S3. Amazon S3 server-side encryption uses 256-bit Advanced Encryption Standard (AES) keys for both object and master keys. This feature is offered at no additional cost beyond what you pay for using Amazon S3. 2. Server-side encryption using customer-provided keys. You can use your own encryption key while uploading an object to Amazon S3. This encryption key is used by Amazon S3 to encrypt your data using ISO 256. After the object is encrypted, the encryption key you supplied is deleted from the Amazon S3 system that used it to protect your data. When you retrieve this object from Amazon S3, you must provide the same encryption key in your request. Amazon S3 verifies that the encryption key matches, decrypts the object, and returns the object to you. This feature is offered at no additional cost beyond what you pay for using Amazon S3. 3. Server-side encryption using KMS. You can encrypt your data in Amazon S3 by defining an AWS KMS master key within your account that you want to use to encrypt the unique object key, referred to as a data key in Figure 8, that will ultimately encrypt your object. When you upload your object, a request is sent to KMS to create an object key. KMS generates this object key and encrypts it using the master key. That you specified earlier. KMS then returns this encrypted object key along with the plaintext object key to Amazon S3. The Amazon S3 web server encrypts your object using the plaintext object key and stores the now encrypted object with the encrypted object key, and deletes the plaintext object key from memory. To retrieve this encrypted object, Amazon S3 sends the encrypted object key to AWS KMS. AWS KMS decrypts the object key using the correct master key and returns the decrypted, plaintext, object key to S3. With the plaintext object key, S3 decrypts the encrypted object and returns it to you. For pricing of this option, please refer to the AWS Key Management Service pricing page. Amazon EBS. When creating a volume in Amazon EBS, you can choose to encrypt it using an AWS KMS master key within your account that will encrypt the unique volume key that will ultimately encrypt your EBS volume. After you make your selection, the Amazon EC2 server sends an authenticated request to AWS KMS to create a volume key. AWS KMS generates this volume key, encrypts it using the master key, and returns the plaintext volume key and the encrypted volume key to the Amazon EC2 server. The plaintext volume key is stored in memory to encrypt and decrypt all data going to and from your attached EBS volume. When the encrypted volume, or any encrypted snapshots derived from that volume, needs to be reattached to an instance, a call is made to AWS KMS to decrypt the encrypted volume key. AWS KMS decrypts this encrypted volume key with the correct master key and returns the decrypted volume key to Amazon EC2. Amazon Glacier. Before it's written to disk, data are always automatically encrypted using 256-bit ISO keys unique to the Amazon Glacier service that are stored in separate systems under AWS control. This feature is offered at no additional cost beyond what you pay for using Amazon Glacier. AWS Storage Gateway. The AWS Storage Gateway transfers your data to AWS over SSL and stores data encrypted at rest in Amazon S3 or Amazon Glacier using their respective server-side encryption schemes. Amazon EMR. CDIS-CP is an Amazon EMR feature that moves large amounts of data from Amazon S3 into HDFS, from HDFS to Amazon S3, and between Amazon S3 buckets. CDIS-CP supports the ability to request Amazon S3 to use server-side encryption when it writes EMR data to an Amazon S3 bucket you manage. This feature is offered at no additional cost beyond what you pay for using Amazon S3 to store your Amazon EMR data. Oracle on Amazon RDS. You can choose to license the Oracle Advanced Security option for Oracle on Amazon RDS to leverage the native Transparent Data Encryption (TDE) and Native Network Encryption (NNE) features. The Oracle Encryption module creates data and key encrypting keys to encrypt the database. The key encrypting keys specific to your Oracle instance on Amazon RDS are themselves encrypted by a periodically rotated 256-bit ICE master key. This master key is unique to the Amazon RDS service and is stored in separate systems under AWS control. Microsoft SQL Server on Amazon RDS. You can choose to provision Transparent Data Encryption (TDE) for Microsoft SQL Server on Amazon RDS. The SQL Server encryption module creates data and key encrypting keys to encrypt the database. The key encrypting keys specific to your SQL Server instance on Amazon RDS are themselves encrypted by a periodically rotated, regional 256-bit ICE master key. This master key is unique to the Amazon RDS service and is stored in separate systems under AWS control. This feature is offered at no additional cost beyond what you pay for using Microsoft SQL Server on Amazon RDS. Amazon Redshift. When creating an Amazon Redshift cluster, you can optionally choose to encrypt all data in user-created tables. There are 3 options to choose from for server-side encryption of an Amazon Redshift cluster. 1. In the first option, data blocks, included backups, are encrypted using random 256-bit ICE keys. These keys are themselves encrypted using a random 256-bit ICE database key. This database key is encrypted by a 256-bit ICE cluster master key that is unique to your cluster. The cluster master key is encrypted with a periodically rotated regional master key unique to the Amazon Redshift service that is stored in separate systems under AWS control. This feature is offered at no additional cost beyond what you pay for using Amazon Redshift. 2. With the second option, the 256-bit ICE cluster master key used to encrypt your database keys is generated in your AWS Cloud HSM or by using a SafeNet Luna HSM appliance on premises. This cluster master key is then encrypted by a master key that never leaves your HSM. When the Amazon Redshift cluster starts up, the cluster master key is decrypted in your HSM and used to decrypt the database key, which is sent to the Amazon Redshift hosts to reside only in memory for the life of the cluster. If the cluster ever restarts, the cluster master key is again retrieved from your HSM. It is never stored on disk in plain text. This option lets you more tightly control the hierarchy and lifecycle of the keys used to encrypt your data. This feature is offered at no additional cost beyond what you pay for using Amazon Redshift and AWS Cloud HSM if you choose that option for storing keys. Three. In the third option, the 256-bit ICE cluster master key used to encrypt your database keys is generated in AWS KMS. This cluster master key is then encrypted by a master key within AWS KMS. When the Amazon Redshift cluster starts up, the cluster master key is decrypted in AWS KMS and used to decrypt the database key, which is sent to the Amazon Redshift hosts to reside only in memory for the life of the cluster. If the cluster ever restarts, the cluster master key is again retrieved from the hardened security appliance in AWS KMS. It is never stored on disk in plain text. This option lets you define fine-grained controls over the access and usage of your master keys and audit these controls through AWS CloudTrail. For pricing of this option, please refer to the AWS Key Management Service pricing page. In addition to encrypting data generated within your Amazon Redshift cluster, you can also load encrypted data into Amazon Redshift from Amazon S3 that was previously encrypted using the Amazon S3 encryption client and keys you provide. Amazon Redshift supports the decryption and re-encryption of data going between Amazon S3 and Amazon Redshift to protect the full life cycle of your data. These server-side encryption features across multiple services in AWS enable you to easily encrypt your data simply by making a configuration setting in the AWS Management Console, or by making a CLI, or API, request for the given AWS service. The authorized use of encryption keys is automatically and securely managed by AWS. Because unauthorized access to those keys could lead to the disclosure of your data, we have built systems and processes with strong access controls that minimize the chance of unauthorized access and had these systems verified by third-party audits to achieve security certifications including SOC 1, 2, and 3, PCI DSS, and FedRAMP. Conclusion. We have presented 3 different models for how encryption keys are managed and where they are used. If you take all responsibility for the encryption method in the KMI, you can have granular control over how your applications encrypt data. However, that granular control comes at a cost, both in terms of deployment effort and an inability to have AWS services tightly integrate with your application's encryption methods. As an alternative, you can choose a managed service that enables easier deployment and tighter integration with AWS cloud services. This option offers checkbox encryption for several services that store your data, control over your own keys, secured storage for your keys, and auditability on all data access attempts. Table 1 summarizes the available options for encrypting data at rest across AWS. We recommend that you determine which encryption and key management model is most appropriate for your data classifications in the context of the AWS service you are using. AWS Service. Amazon S3. Model A. Encryption method and KMI Model B. Client-side solutions. Using customer-managed keys. Bouncy Castle, OpenSSL, Amazon S3 encryption client in the AWS SDK for Java. Client-side partner solutions with KMI. For customer-managed keys. SafeNet Protect app for Java. Client-side solutions. For customer managed keys in AWS Cloud HSM. Custom Amazon VPC EC2 application integrated with AWS Cloud HSM client. Custom Amazon VPC EC2 application integrated with AWS Cloud HSM client NA. Model C. Server-side encryption using AWS managed keys. Amazon S3 server-side encryption. Server-side encryption with customer-provided keys, or server-side encryption with AWS Key Management Service. All data is automatically encrypted using server-side encryption. Amazon S3 server-side encryption. Amazon Glacier. NA. Trend Micro Secure Cloud, SafeNet Storage Secure. AWS Storage Gateway. Amazon EBS. Oracle on Amazon RDS. Linux block level, LoopIce, Decrypt, with or without LUKS, and TrueCrypt Linux file system, eCrypts and EncFS Windows block level, TrueCrypt Windows file system, BitLocker Linux block level, LoopIce, Decrypt plus LUKS and TrueCrypt Linux file system, eCrypts and EncFS Windows block level, TrueCrypt Windows file system, BitLocker, EFS Bouncy Castle, OpenSSL. Trend Micro Secure Cloud, SafeNet Protect. Custom Amazon VPC EC2 application integrated with AWS Cloud HSM client. Amazon EBS encryption with AWS Key Management Service. Cipher Cloud Database Gateway and Voltage Secure Data. Custom Amazon VPC EC2 application integrated with AWS Cloud HSM client. Microsoft SQL Server on Amazon RDS. Bouncy Castle, OpenSSL. Cipher Cloud Database Gateway and Voltage Secure Data. Amazon Redshift. NA. Amazon EMR. eCrypts. Custom Amazon VPC EC2 application integrated with AWS Cloud HSM client. Encrypted Amazon Redshift clusters with your master key managed in AWS Cloud HSM or on-premises. SafeNet Luna HSM. Custom Amazon VPC EC2 application integrated with AWS Cloud HSM client. Transparent Data Encryption, TDE, and Native Network Encryption, NNE, with optional Oracle Advanced Security License. TDE for Microsoft SQL Server NA. Encrypted Amazon Redshift clusters with AWS Managed Master Key. CDS-CP using Amazon S3 server-side encryption to protect persistently stored data. Table 1, Summary of Data at Rest Encryption Options. References and further reading. Bouncy Castle Java Crypto Library. http://www.bouncycastle.org/ OpenSSL Crypto Library http://www.opensl.org/ Cloudberry Explorer Pro for Amazon S3 Encryption. http://www.cloudberrylab.com/Amazon S3 Explorer Pro CloudFront IAM.asks. Client-side data encryption with the AWS SDK for Java and Amazon S3 http://aw.w.s.articles/2850096021478074. SafeNet encryption products for Amazon S3, Amazon EBS, and AWS Cloud HSM. http://www.safenetincorporated.com/ Trend Micro Secure Cloud. http://www.trendmicro.com/a/enterprise/cloud solutions/secure cloud/index.html. Cipher Cloud for AWS and Cipher Cloud for any app. http://www.ciphercloud.com/ Voltage Security Secure Data Enterprise. http://www.voltage.com/products/secure data enterprise/ AWS Cloud HSM. https://aw.s.amazon.com/cloudsm/ AWS Key Management Service. https://aw.s.amazon.com/kilometers/ Key Management Service Cryptographic Details White Paper. https://d0.awsstatic.com/whitepapers KMS Cryptographic Details.pdf. Amazon EMR CDS-CP to encrypt data in Amazon S3. http://docs.aws.amazon.com/elastic MapReduce/latest/developer guide/using mr_cdis-cp.html. Transparent data encryption for Oracle on Amazon RDS. http://docs.aws.amazon.com/Amazon RDS/latest/user guide/appendix.oracle.options.html #appendix.oracle.options.adv Security. Transparent data encryption for Microsoft SQL Server on Amazon RDS. http://docs.aws.amazon.com/Amazon RDS/latest/user guide/chap_scleserver.html #scleserver.concepts.general.options. Amazon Redshift encryption. http://amazon.com/redshift/fax/number0210. AWS Security Blog. http://blogs.aws.amazon.com/security. Document revisions. November 2013, first version. November 2014. Introduced section on AWS Key Management Service, KMS, and Amazon EBS in Model C. Updated sections in Model C for Amazon S3, Amazon Redshift.